Hello everybody, my name is Cameron Poole. Today we're going to be doing a protocol presentation video over the transport protocol. We're going to be looking at TCP and UDP today. So let's just go ahead, but before we jump into TCP and UDP, we should look at the OSI model to review where we're going to be working today. So the OSI model is comprised of 7 layers, the topmost being layer 7, application layer. We got layer 6, presentation, layer 5, session, layer 4 is transport, the layer we're going to be working with today with TCP and UDP, the layer 3, network, layer 2, data link, and layer 1, the physical layer. So an acronym that I use and I like to remember this 7-layer model is all people seem to need data processing. That's helped me out along the way for sure. So let's look at the transport layer of the OSI model. The transport layer is going to be responsible for end-to-end host-to-host communication over a network. There are going to be 2 types or 2 methods of communication that is supported by the transport layer. The first one being connection orientated. So this means that a connection between endpoints are going to be established before communication starts, and this is used with TCP. And we've also got connectionless communication, which does not require a connection to be established before communication start, and this is used with UDP. So again, we're going to be working on layer 4 out of 7, the transport layer. And again, this is going to involve data delivery between 2 endpoints. And this is done through data stream, which is a method of connection-oriented communication. TCP uses data streams, which are sequences of data, packets, used for communication. And TCP does this through synchronization numbers. So it can take the packets and organize them in the correct manner, if they don't already come in the right sequence. And we got datagrams, and this is going to be used for connectionless communication. And these are individual packets that are sent over the network. Arrival of datagrams is not guaranteed with UDP. There's no connection established. There's no error checking established. They're just sent, and they're not really sequenced or anything like that. They just come, and we hope you get them in the way you want them. So let's take a look at user datagram protocol. I'll refer to it as UDP from now. And UDP is used to send messages as datagrams to hosts. So it sends datagrams, individual packets, to an endpoint. UDP does not require an established connection between hosts before communication starts. Remember, it just kind of sends it as an individual packet, no sequence. There's no error checking in UDP. So if there's something wrong with the packet and a router spots it, it's just going to drop that packet and you won't see it. It won't ask for retransmission. This is often used in streaming. One big streaming platform now is Twitch, and this uses UDP. And sometimes we get lag, or we skip around, and that's usually us not getting a packet or the packet being lost. And this is extremely fast because you don't have to establish a connection, and there's no error handling, there's no retransmission, so it doesn't have to worry about that. It makes it a little bit faster than our current topic, transmission control protocol. And I'll refer to this as TCP from now. TCP is going to be connection orientated. It's going to use data sequence, and this is used by sequence numbers to identify data, so it can be organized if it doesn't already come in the right sequence. This does require a connection, TCP. TCP does this by what's called the 3-way handshake, and this is a series of synchronization and acknowledgement requests between hosts and endpoints before communication starts and transmission of data starts. TCP does involve error detection, so it can spot an error and ask for retransmission. This is really good for like web browsing, web surfing, file transfers. So yeah, this is often used for file transfers. And TCP is extremely reliable because it does all this extra work of setting up a connection, asking for retransmission if there's an error. But with all this extra work, it can be slower than UDP. It's a little bit more hefty. So when do we use UDP? We use UDP quite often if you like gaming or watching streams or talking to friends online. Well, it's used with more specifically a protocol named VoIP, Voice over IP. Some applications that use this are going to be Skype, Discord, and TeamSpeak. I know Skype and Discord are used for many organizations for conferences and video conferences, and it's nice that we use UDP in this manner, because if there was to be error checking, then if there was to be error checking and we needed a packet to be resent, then we might not receive it in the right way. So it'd actually be more efficient if we just lost that packet, didn't see it, so there's no confusion, and we can then just ask someone in the conference later and hope that packet comes through. So it makes it a little bit more easier and a little bit more concise. UDP also uses a DNS. DNS uses a UDP, but it can also use TCP. But the default for DNS is going to be UDP on port 53, but DNS can use TCP if UDP isn't acting right. Since there are no error checking in packets with UDP, and they may not be delivered because there's no error checking, UDP is super fast. Ka-chow. So when do we use TCP? TCP is used for many things, like web browsing with HTTP, file transfer protocol. We use this for downloads sometimes. POP3, this is used for receiving emails, and also DNS. But remember, the default's UDP, but if UDP isn't acting right, we'll use TCP for DNS. So let's look at the similarities between these two. So they both provide methods for sending and receiving data on the network. They just operate differently, but overall, they're under the transport protocol. They handle, or they make sure data is delivered. Well, not make sure, but these are used for sending and receiving data. Both can be used on the same port in some circumstances, so that's kind of a similarity. Packets are routed in a similar manner. So again, the router is going to decapsulate the frame, and it's going to do all its checking and then send it. That's not going to change too much whether you're using UDP or TCP much. The only time it's really going to do much of a difference is when there needs to be a retransmission. That's where their differences really start to shine, and when the connection is established. But they're both built on top of the IP protocol, meaning that regardless you're sending or receiving information, it's still going to use IP addresses to get it to a host. The differences between UDP and TCP. UDP is a connectionless protocol, while TCP is a connection-based or connection-oriented protocol. Remember, TCP does the acknowledgement, three-way handshake, sequences, and requests to set up a connection, while UDP just kind of sends it and hopes it gets there. UDP doesn't provide error checking, while TCP does. This is a big function for TCP. Retransmission of data. We want our data to arrive correctly, and this does come at a cost, it being a little bit heavier, where UDP is a lightweight protocol and TCP is heavyweight. Since TCP has to do all this extra work with error checking and setting up a connection, that's going to take a little bit more work on TCP's side, while UDP doesn't have to worry about that, so it's not included. It makes it a little bit faster, a little lightweight. Another big difference is the header size of the packets themselves. UDP header size is going to be 8 bytes, while TCP headers are going to be 20. So again, today we've worked on the layer 4 of the OSI model, the transport layer. This is used with data streams and datagrams. Data streams are going to be sequences of packets, while datagrams are individual packets. We've talked about UDP and TCP. The similarities of the two are the overall function. Remember, these are how packets are generally sent and received. They may use the same port in some circumstances, and they're both built on the IP protocol. The differences between the two include how the data is delivered, how the data is handled, the reliability and speed. Remember, the delivery of TCP is a little bit different. It is going to be delivered in sequences, not individual packets. And how the data is handled, TCP can ask for retransmission. It can it can organize it by its sequence numbers. UDP does not do that. The reliability of TCP, it sets up a communication, has error checking. TCP is a lot more reliable, but UDP is faster because it doesn't have to do all this extra work. So thank you guys for watching my video over the transport protocol, TCP and UDP. I hope you guys have a nice one. Thank you.